The Makerspace printers are all FDM printers. You are welcome to visit the wiki to see what printer models are available for use in the Makerspace. FDM printers extrude a melted material through a nozzle, just like a hot glue gun. As material is extruded, the print head moves along a path predefined for various layers. Think of slicing a 3D model along its height into 2D images which are then pathed. If these 2D images are stacked in order, then the 3D model is reformed. Finally, you will be surprised at the variety of materials that can be used in FDM printers. For instance, the GIF on screen is that of a chocolate mug being printed. Some might argue the use of such a mug, but it makes for a good example. On that note, let's talk materials. FDM printers typically use PLA or ABS. PLA, or polylactic acid, is biodegradable in industrial composters. It is strong, but not very ductile. PLA is easy to print with, and has a noticeable corn smell. ABS, on the other hand, makes stronger parts, but is harder to print with as it requires better temperature control. Other materials that can be used in FDM printers are pt3, nylon, NinjaFlex, and even metals such as titanium, mild and tool steel, stainless steel, copper, and even Inconel, a superalloy. pt3 can be seen as a chemically resistant PLA alternative given its strength and ease of printing, though it is slightly more ductile. Nylon is also ductile, though it is much stronger. It should be noted that nylon prints very hot and absorbs moisture, and such it is much harder to print with unless you have specialized equipment. NinjaFlex, a material available at the Makerspace, is an interesting material that allows for flexible prints, though printing with it can be quite difficult. As for the metal choices, FDM printing with these can be very expensive, as they require post-processing in a gas-powered sintering oven. Despite this, the parts may still end up cheaper compared to the cost of the same parts manufactured subtractively, depending on the part complexity. Finally, one last subject should be discussed before we finish these slides, and that is of support structures. 3D printers need to build onto an existing surface to produce a successful model. Since printers print in layers, the printer might start printing in the air if a model contains overhangs. As a designer or 3D print programmer, you're faced with two options. Either design and orient your prints to have no overhangs, or make sure you include support structures when slicing your model. Thankfully, slicing software typically adds support structures automatically to a print when you specify that you want some. On top of this, support structures are designed to be easy to break off from prints, though some can be hard to remove if they are generated in a volume that is hard to reach. Because of this, some printers can print soluble support structures. As a final note, if your overhangs are at an angle that is steep enough, the print will not need any supports. Have a look at the wiki if you are wondering what is considered to be a safe angle.